Hi everybody, welcome to the second video that covers section 3.4, and here we will go over the 4 application problems that you have in your homework assignment for this section. And this one would be the first one, which is example 5 in your notes. You have negotiated a price of $25,200 for a new Bison pickup truck. Now, you must choose between 0% financing for 48 months or a $3,000 rebate. If you choose to rebate, then you qualify for a credit union loan at a balance of 7.5% compounded monthly for 48 months. Which options should you choose? Okay, so basically you have 2 options. You can either pay the entire price and have 0% financing, or you can take a $3,000 rebate and then you can borrow the rest of the loan at 7.5% compounded monthly for 48 months, and that is an annual percentage rate. Now, the best way to determine which is the best is to compare what the monthly payment will be. So we are going to compare monthly payments. Okay, if you choose 0% financing, then your payment is going to be the entire cost of the car, which is $25,200, divided by the number of payments, which will be 48. And that will be equal to, well, let's check this out on our calculator, 25,200 divided by 48. That is $525. That will be your monthly payment for 48 payments. Now, if you chose the $3,000 rebate, then you need to borrow the rest of the money. So the amount that you're going to borrow, which would be the present value of your loan, is going to be $25,200 minus $3,000, which of course will be equal to $22,200. That's how much you're going to borrow. And the question here is, what is your payment going to be? Well, we can use the amortization formula for that. Your payment will be equal to your present value times I divided by 1 minus the quantity 1 plus I raised to the negative n power. Okay? Now, what we need to do is figure out what I and n are. Well, we're making monthly payments for 48 months, so that basically means that n is equal to 48. To figure out I, we first need to figure out what R is, and R is going to be 7.5%, which is equal to 7.5 divided by 100, which will give us 0.075. Okay, and then I is going to be R divided by M. M is going to be 12, since we are compounding monthly. So here we will have 0.075 divided by 12, and that will be 0.075 divided by 12 is 0.00625. 0.00625. So you know what n is, so it's actually given to us, it's 48 months. We know what I is 0.00625. We can come on in and figure out what our payment is. Our payment is going to be our present value, which is now $22,200 thanks to the rebate, times I, which is 0.00625, divided by 1 minus 1 plus I, no, 0, hang on a second. We can go ahead and figure that out. We don't need to write that down like that. We can write that down as 1 minus 1.00625, and that will be raised to the negative 48 power. Okay, so once again, we're going to basically compute the numerator, then we're going to compute the denominator. For the numerator, we have $22,200 times 0.00625. And that's our numerator. Our denominator, we're going to have 1 minus 1.00625. And we're going to get to our exponent, negative 48. That is our denominator. And then finally, to get the payment, let's highlight the numerator. There it is. Divided by, highlight the denominator, hit enter again, and that is your answer. We have that our payment is going to be $536.771, which basically in dollars and cents rounds to $536.77. So if you took 0% financing, you will have the monthly payment of $525. If you took your rebate, your monthly payment will increase by a little more than $11 to $536.77. So you would pay more if you took the rebate. You want to take the 0% financing. Turns out that the interest that you have to pay exceeds the value of the rebate. Now our next example are installment loans. In here, we have a sailboat that costs $30,000, $30,243, and you've made a 5% down payment, and you're going to amortize the rest, which basically means you're taking out a loan for the rest, with equal monthly payments over a 15-year period. So it's kind of like you're taking out a small mortgage for a sailboat. If you must pay 6% interest, annual interest, compounded monthly, the first question is, what is your monthly payment? Okay, and the next thing we want to figure out is how much total interest we will pay. Now, your monthly payment, once again, we will figure out using the amortization formula, which is that your payment is equal to your present value times I divided by 1 minus the quantity 1 plus I raised to the negative n power. All right, and then your interest will be equal to the amount that you have to pay back minus the amount borrowed. Okay, so the amount that you had to pay back is going to be equal to your payment, your monthly payment, or your periodic payment, times the number of payments that you had to make. And the amount that you borrowed is the present value of your loan. All right, so before we can do A, we actually need to figure out what the present value of our loan is. And before we can do that, we need to know what our down payment was. How much did you actually pay up front? You made a 5% down payment. Therefore, that's going to be equal to the cost of the boat, which is $30,243, times 5% as a decimal, which would be 0.05. And what will that give you? Well, let's go ahead and find out. 30,243 times 0.05. That gives me $1,512.15. The rest of the money you're going to have to borrow. The amount borrowed, which by the way is your present value, is going to be 30243 minus 1512.15. So that will be, on your calculator, 30243 minus, well, that's the amount that your down payment is. We can just go up and highlight that. Then hit enter again, and that is the amount that you borrowed. And that is $28,730.85. Okay, so we know what PV is. Now we need to figure out what I is. Now remember, R, before we do that, we need to figure out a few other things. Notice here that our period is 15 years. So T is equal to 15. R is equal to 6.6%, which is equal to 6.6 divided by 100, or 0.066. And we're making monthly payments. That means that M is equal to 12. So N is going to be equal to M times T, which is 12 times 15, which is equal to 180. How do I know that? I've done a number of 15-year mortgages in my time. And then I is equal to R over M, which will be 0.066 divided by 12. 0.066 divided by 12 is equal to 0.0055. And now we know everything we need to know to figure out what our monthly payment is going to be. Our payment, hope I have enough space here, is going to be equal to $28,730.85 times 0.0055, that's I, 1 minus, doing this addition here, 1.0055, and that will be raised to the negative 1/80th power. So we just need to figure this out in our calculator. We're going to do this the exact same way we've done all the other ones. We're going to compute the numerator and then compute the denominator. So for the numerator, we have 28730.85 times 0.0055. That is our numerator. For our denominator, we will have 1 minus 1.0055 exponent negative 180, and that is our denominator. So our payment is going to be the numerator, the value of the numerator, right there, hit enter, divided by the value of the denominator, hit enter to do the math, and that is your answer. And we have that our payment is going to be equal to $251.858. We want this in dollars and cents. We have it 8 in the third decimal place. So this will become $251.86. That will be your monthly payment. Now with that, we can figure out the interest rate. Now remember, the interest rate is going to be equal, or no, not the interest rate, but the interest is going to be equal to the amount you paid back, which is going to be your monthly payment $86, and the number of times you made that monthly payment, which actually happens to be 180 times, minus the amount you borrowed. Not the cost of the boat, but the amount you borrowed. The amount that you borrowed is $28,730.85. So now we just need to compute that. Here we will have 251.86 times 180 minus 28730.85. And then the amount of interest that we will have to pay will be $16,603.95, which ironically is more than half of the cost of the boat. Now we're going to talk briefly about amortization tables. Now, if you take out a loan which is amortized like your mortgage or your car payment, but in particularly a mortgage for your house. It is common, actually, it is required for the lender to provide you a chart that shows you for each payment the amount of interest that is paid and the amount of money that is going to be allocated towards reducing your balance, and then the new balance after the payment. And this chart is called an amortization schedule. And one of the things you're going to have to do in your homework is actually construct such a schedule. And that is going to be down here in example 7, which is your third homework problem. And that's what we're going to do here. So here we want to construct an amortization schedule for a $16,000 debt that is supposed to be amortized or paid off in 12 equal semi-annual payments at 6% per half year. So that's over the period on the unpaid balance. And this is your schedule. Notice, look what we have here. We have the payment number. We actually have your payment, your monthly payment, or your periodic payment, your interest, your unpaid balance deduction, how much your unpaid balance goes down, and your unpaid balance. And one of the primary entries we have here is your payment. And before we can put in our periodic payment, we need to figure out what this is. But to be precise, this right here is PMT, and we need to figure that out. And this point right here, at this point, is the present value. Now, the present value is going to be the amount you borrowed. You borrowed $16,000, so $16,000 goes here. Now, before we can continue, that was a mistake. That shouldn't be PMI. That should be PMT. Before we continue, we need to figure out what our payment's going to be. And of course, that requires using our amortization formula. PMT is equal to PV times I divided by 1 minus the quantity 1 plus I to the negative n power. Okay, now here they've given us n. It is 12. And they have given us I. That's because that's interest per half year. We're making payments every half of a year. So I is 6%, but we cannot use percentage. We have to write that as a decimal. So that would be 6 divided by 100, or 0.06. So now we have I. We have n. We know what the present value is. That is $16,000. We can figure out what our payment is going to be. Our payment is going to be equal to $16,000. Almost did that wrong. Times, another zero there, times I, which is 0.06, divided by 1 minus 1 plus I, which is 1.06, raised to the negative n power, or negative 12. And of course, we're going to compute this the way we have computed it before. First, the numerator, 16,000, times the interest, 0.06. That's our numerator. The denominator is going to be 1 minus 1.06 raised to the negative 12th power. That is our denominator. Then the payment will be equal to the numerator divided by the denominator, and we get that our payment is going to be $1,908.432. Notice we only care about dollars and cents. Notice that the third decimal place is less than 5. So our payment will be equal to $1,908.43. And we're going to make 12 payments of $1,908.43. And that is what we want to put in every single row under the payment column, with, of course, excluding, of course, payment 0. Okay, there I am finished. Now, this column is the interest column. And this is going to be equal to the interest rate, which is I, or 0.06, times the unpaid balance of the previous of the previous row. Okay, the unpaid balance reduction is going to be equal to the payment minus the interest. Okay, and then the unpaid balance is going to be the unpaid balance of the previous row minus balance reduction. So that's pretty much what we're going to do. Now, it looks a little daunting, but if I walk through this a couple of times, I think you'll actually get it. Now, we want to start off with figuring out, so we're down here, we've made our first payment, and we want to figure out what the interest is. Okay, or how much of that is going to go to the interest. Well, the amount that's going to go to interest is going to be the unpaid balance in the previous row, which is 16,000, times the interest, which is 0.06. We get 960. That goes here. The unpaid balance reduction is going to be the monthly payment, 1908.43, minus 960. This is the value right here. Because remember that your payment's either going to go to interest or paying off the principal. And that's going to give you $948.43. $948.43. And then finally, your balance is going to go down by $948.43. Namely, your unpaid balance is going to be equal to 16,000 minus 948 point, oh, that's not a point. Delete, 0.43. And that gives me $15,051.57. There you go. And that is your new balance. So how do you do row 2? We just go ahead and do it again. This is now the previous row. So we're going to take this value and multiply it by 0.6. On the calculator, that's pretty straightforward. We can just do times 0.06. Now 0.6, and that is our and that is how much of our next payment is going to go to interest. Actually, a little bit less. So we have 903.094. That will round to 903.09. Okay. The rest of your payment is going to go to your unpaid balance. That is going to be 1908.43 minus, now you really can't use this. You should probably use the rounded version of it, which is right here. 903.09. And it turns out that the amount that's going to balance reduction is going to be $1,005.34. Okay, and then your principal is going to be and then to compute your reduced principal, just go back to your previous principal, which by the way is right here. 1501.57, hit enter, minus the value above, and that, hit enter again, that is your new principal. So after your second payment, you will still owe $14,046.23. Now, I'm going to go through the entire thing. Obviously, I don't expect you to watch the entire video unless you still need more help. So if you kind of got this, then you can just zoom on to something else. If you're still trying to figure it out, please feel free to pay attention as I wade on through the entire thing. Okay, so this is my new balance. I'm going to multiply this by 0.6. I can do that by going times 0.06. 0.06. Okay, that is how much of my next payment is going to interest. That will round to 842.77. The amount of the next payment that will go to principal will be 1908.43 minus not this value, but that value down there, 842.77, and that will be 1065.66. And then my new principal is going to be the previous principal right there, minus my reduction, enter, and that will give us $1298.50 or $12,980.57. $12,980.57. Multiply that by 0.06 times 0.06. That gives me 778.83. I guess I could go up to here, hit enter. Actually, I think this takes too long. 778.83. That gives me a new reduction of $1,129.60. Okay, that means our new principal is going to be equal to the previous principal, $12,980.57, minus our reduction, and that will give us $11,850.97. Multiply that by 0.06 times 0.06. That will give us $711.06 when we round up. Okay, and then that means that the amount that's going to be applied to our balance is going to be 1908.43 minus 711.06. That gives me 1197.37. 1197.37. And then our new balance will be our previous balance minus the reduction, and we are about ready to break 10,000. We got $10,653.60. Okay, multiply that by 0.06. And that will give us $639.22. That's how much of the next payment will go to interest. The amount that will go to principal will be 1908.43 minus 639.22. That is 1269.21. And then our principal reduction will be our previous principal, which is 10653.6 minus our reduction. And we are now below $10,000. We are at $9,384.39. All right, multiply that by 0.06 times 0.06. Okay, that will give us $563.06. That's how much goes to interest. The rest goes to principal. That will be 1908.43 minus 563.06. That will give us a 1345.37, and then our new principal will be the previous one, $9,300 minus our reduction. And look, it's going down. It's getting pretty small now. We're now down to $8,039.02. Now notice we have made 7 payments, but we still only paid off less than half the principal. Okay, what is our next? How much of our next payment is going to go to interest? Well, that's going to be the previous principal times 0.06. That gives us $482.34. $482.34. The rest of the payment will go to the principal, or to paying off the balance. That will be 1908.43 minus 482.34, and that means that $1,426.09 will go to paying off the principal, or paying off the balance. So I'm using balance and principal interchangeably. So the new principal is going to be equal to the old principal minus the reduction, and that is $6,600, or $6,612.93. Multiply that by 0.06 times 0.06. That gives me, when after rounding, $396.78. Okay, our balance, the amount that's going to go to balance is going to be 1908.43 minus that amount, 396.78, and that gives us $1,511.65. So our balance reduction, or our new balance, is going to be our old balance minus our reduction, and that will be $5,101.28. Multiply that by 0.06. Oh, did that again. Let me try that. Let's try that one more time. That by 0.06. That gives me, after rounding, $306.08. Okay, that's the amount that goes to interest. The amount that goes to principal will be 1908.43, 1908.43 minus 306.08, and that will give me 1602.35. And then our new balance is going to be our previous balance, 1501.28, minus our reduction, which is 1602.35, and that will give us 3498.93. Okay, multiply that by 0.06. Let me see if I can do it right this time. Times 0.06, and that is how much of our next payment is going to go to interest. And that will be, after rounding, we have a 5 there, will be 209.94. Okay, the rest of our payments going to go to interest, so that is 1908, sorry, 0.43 minus 209.94, 209.94, and that will give you 1698.49. And then our revised balance is going to be our previous balance, 34.98, minus our reduction, and that will give us $1,800.44. And we have one more payment left. So when we make our last payment, 0.06% of that will go to interest. So we multiply our previous answer by 0.06. That comes to $108.03. Oh, 3 cents, not 30 cents, 3 cents. There we go. And then the rest of that payment will go to pay off the interest, or pay off the principal. So that will be 1908.43 minus 108.03, and that gives us $1,800.40. And then when we do the subtraction, I don't think we need to use the calculator for that. It turns out we still have an unpaid balance of basically 4 cents. And why does that occur? Well, that basically occurs because of the rounding we're doing after we multiply it by the interest rate, which is 0.06. So there's a couple of rounding errors in here when we round down to the nearest cent. So we have 4 cents left over. Sometimes when you do this, it'll come out clean. Sometimes when you do this, it'll come out with a handful of cents, just like we do in this particular case. But this is indeed correct. I've checked it a number of times, particularly even using a little program I have that does this rather automatically. But that's the general approach that you want to use when you do this. I know this is kind of long and tedious, but as you can see, you're basically doing 3 calculations for every single row, and you can do them rather quickly when you're not talking through them the way that I just was. So, and this brings us to our last example, which is example 9, which is the purchase of a house. So you have a friend. I know I'm as shocked as you guys are. And that friend tells you that they paid $16,000. That's supposed to be a comma, not a period. Sorry about that. One of my many, many typos. Down on a new house, and they are to pay $677 per month for 15 years. And the question here is, if the interest is 6.6% compounded monthly, what must be the selling price of the house? Well, keep in mind, the selling price of the house is equal to the down payment plus the amount borrowed, which will be equal to $16,234 plus whatever the present value of the loan is. The present value of the loan can be found using the present value formula, which is going to be your payment, times 1 minus the quantity 1 plus I raised to the negative n power divided by I. Okay, well, we know that their payment, I forgot the T there, is equal to $677. Okay, we know that the duration is 15 years. We know that they are making monthly payments, so our compounding frequency is going to be 12 months per year. And we know that our interest rate, our annual interest rate, is equal to 6.6%, which is the same in the decimal as 0.066, 6.6% divided by 100. So we need to figure out what I and N are, and I'm going to kind of do that down here. So we have that I, which is R divided by M, is going to be 0.066 divided by 12. And that's going to be equal to, well, 0.066 divided by 12, 0.0055. You've actually seen that before. And then N is going to be equal to M times T. That is 12 times 15, and that is 180. So now we know everything we need to know. So we have N, we have I, we have that our present value, the amount borrowed, is going to be equal to $677 times 1 minus 1 plus I, which is 1.0055 raised to the negative 1/80th power, all divided by I, which is 0.0055. Now, I showed you one way to compute this on your calculator. I'm actually going to show you another way now. And this way involves computing this first and then multiplying it by the present value and then dividing it by I there. So let's go ahead and do it that way. So the first thing I'm going to do is 1 minus 1.0055 exponent negative 180. There we go. That's what this is right here. Okay, I am going to multiply that by my present value times 677, and I'm going to divide it by the interest rate, or divide it by I. 0.0055. And that gives me a value of $77,228.961, and that will round to $77,228.96. Now remember, the selling price of the house is going to be equal to your down payment plus your present value. So the selling price will be equal to your down payment, $16,234, plus the amount you borrowed, which is $77,228.96. So what we need to do here is plus 16,234, and ignoring the 175 there, that will be your answer. It turns out that the cost of the house was $93,462.96. Okay, now the question here is how much interest did they pay in those 15 years? Now remember, the interest is equal to the amount you paid minus not the cost of the house, but the amount borrowed. Okay, the amount you paid is your monthly payment times the number of payments made minus the present value of your loan. That is going to be equal to 180, that was the number of payments, times 677, that was the amount that you paid every single month for 15 years, minus this value right here, 7722 or 228.96. And when you do that computation, you will have 180 times 677 minus 77,228.96, and the interest will be $44,631.04. Right there. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. I know this was kind of long, but you don't have to go through the entire example for the amortization schedule. Just go through it long enough so you're comfortable with what you're doing, and then just have at it. And if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.